In this video, I'm going to be comparing the slide rule on the 600D flaw detector from Olympus to the paper slide rule. I'll just notice what some differences are. The first thing I noticed when I started playing around with the slide rule on the 600D is that for conductivity, you only have two choices. You have percent of international annealed copper standard percentage, and then that works with inches or mils, or you have megasiemens per meter, which is metric, and that works in accordance with the green side of the cardboard slide for millimeters. The next thing I noticed is that when you hit the next button and you go through the materials, it just goes in steps. So it looks like what they did was they took the information from the paper slide rule, and if there's like 12 or 14 different materials across the top, those are the only ones that got put in here. So you can't dial it in for a very specific resistivity, for example. Now, a moment ago I said they only have megasiemens per meter and percent IACs. What they don't have is resistivity. Now, you can always calculate that, by a formula, use your calculator. But a lot of times if you're looking for the conductivity somewhere and that only gives you the resistivity value, if you have the 600D and no calculator, you're kind of stuck. But if you have this paper slide rule, you'll notice the three scales for here for conductivity are megasiemens per meter for the top scale. Right below it, you have conductivity and percent IACs. And then below this black box, you have the resistivity in micro-ohm centimeters. So as long as you know one of the three, you can perform your calculations with the paper slide rule. Another thing is, with the 600D, it just says depth. So if you have megasiemens per meter in there and then you dial in a particular material like Monel, and then you go down and adjust the frequency to 200 kilohertz, it says depth, 0.78 millimeters. Well, it doesn't say if that's effective depth of penetration, which is closer to 3 standard depths, or if it's standard depth of penetration. Now I know that it's standard depth of penetration because I did a spot check with my slide rule and came up with the same answer. But it would be nice if they would have said, if they would have defined what depth is a little bit better. The next thing is, if you wanted to check the standard depth of penetration for a material that, for example, was, let's say 14 micro-ohm centimeters, you can't really do that on here because if I change that, well, number one, it doesn't have micro-ohm centimeters. So 14 micro-ohm centimeters would be the same as about 12 IACs. So watch what happens when we try to dial in 12 IACs. Can't get there. It just skips right past it. That's because they only put certain values in there, but not all the in-between graduations. So you're a little bit more limited with the slide rule on the 600D. Here, you can go anywhere from 0.1 megasiemens per meter all the way up to 100 megasiemens per meter. Or in IACs, you can go from 0.2 IACs all the way to 150 IACs. And for micro-ohm centimeters for resistivity, you can go to 1,000 micro-ohm centimeters all the way down to 1 micro-ohm centimeters. All right, so the next thing would be, there's no real visual aids to help the operator kind of understand what's going on with depth of penetration, separation angles, knee of the curve, thinning locust, all that stuff that's related to eddy current physics. But on the paper slide rule, the latest edition of it, it's got this graphic in the lower left-hand corner, a couple graphics that, visually explain where 1, 2, and 3 standard depths of penetration, you can imagine what the density looks like as you go down through the material. And then the thinning curve, conductivity curve, and lift-off locus will help you understand, how different standard depths of penetration correlate to a thinning curve and to different standard depths of penetration. You can see right there where it meets the conductivity curve. That's where you got about 5% of your eddy currents available for use, so they're pretty useless. Another thing that you can do with the slide rule, there's about 3 or 4 more things. One of them is, although the 600D digital slide rule will give you the standard depth of penetration if you know the conductivity and the material, if it's in the list here, you'll get the standard depth of penetration, but it doesn't tell you what frequency to put in to achieve one standard depth at a particular location within the material. I may have said that wrong. I'm sure somebody will catch it in the comments. Another thing is calculating F90. That's not an option on the 600D. But when you have the slide rule, all you do to calculate F90 for surface, you just put this red hairline to 0.8, and then you'd put your material right under it. We're going to use kilohertz. That's the middle scale here. So if we said 0.8 at 50 mils for tungsten, let's say, right there, 5 kilohertz would give you F90. So I'd give you a 90-degree separation between your shallow IDs and shallow far surface indications. Now, if I was going to calculate F90 for tubing, instead of setting 0.8 at the far surface, we just use 1.1 at the far surface. So another example, let's go to, we're going to use Inconel. So set it to 1.1, and Inconel tubing and steam generators, for example, is like close to 50 mils again. So if we put 50 mils at the red hairline, right about there, and then move the slider over to Inconel, our F90 frequency is about 180 kilohertz. Okay, so that's F90 for surface and tubing. And then one last thing you do is you can, what we were really doing there was calculating the right frequency to get a separation angle of 90. But when you're doing like tubing and you're using phase for sizing, like OD flaws or far surface flaws, you'll use a phase versus depth curve. And normally what you do, you pick a frequency that will have your really shallow far surface flaws, probably around 170 degrees or so. So let's just imagine a 1%er was out there at 170 degrees. Instead of going to 1.1, you'll just move this red hairline, and now we're gonna use the bottom scale for separation angle. We'll put that over to like 170. And again, this is just all ballpark. Get you close, and then once you dial that frequency that you selected into your instrument, then you can fine tune it, adjust it, and verify that you're seeing what you expect to see. So I put my red hairline at 170. I'm gonna go back to the 50 mils, and then I'm gonna swing over to Inconel again. And now it shows you about 440 kilohertz. So that's probably gonna be your prime. Your F90 was gonna be like closer to 180. Again, you might have to fine tune them. I think the real frequencies we use are 400, 200, 135 kilohertz. So that in a nutshell is, a handful of things that you can do with the paper slide rule that you can't with the 600D.